Okay, everybody, I'm going to have another review of some Alg 2 things here. We're dealing with nonlinear inequalities. You want to get your notebook out and you want to title this Graphs of Nonlinear Inequalities. And we're going to be doing kind of a bit of a focus on absolute value inequalities. So make sure you put that title up there. One of the questions that we're going to answer is how do we graph polynomial, absolute value, and radical inequalities with two variables? And we're also going to solve some inequalities as well. So again, remember you can pause at any point and back up to listen to something again. So let's take a look and see what you remember. Okay, so we want to first take an inequality. Here's an inequality statement right here. Y is greater than the absolute value of x plus 1 minus 2. And I want to know if negative 1, 2 is a solution, and how can we tell? Well, there's two ways we can do that. One is a numerical check and then one is a graphic check. So numerical check, you're probably pretty comfortable with this, is how do I check my solutions to equations or inequalities? Well, you substitute them back in to see if the statement is true. So 2 is my y value, so remember xy, and is this a true statement? Well, 2 is greater than, what's that, 0, absolute value of 0 is 0. Is 2 greater than negative 2? And yeah, it is greater than negative 2, so apparently it is a solution. Another way, hey, this seems like a function that I should be able to graph. Well, I should say the inequality. So I want y is greater than the absolute value of x plus 1 minus 2. Well, that sounds familiar. So x plus 1, that's a shift of 1 to the left. And minus 2, that's a shift down 2 on the xy axes. So right there is the v of my vertex, and I'm going to graph this inequality. Now it's not equal to, so I'm going to do dotted lines. All of these have slopes of 1 and negative 1. And I want all the y values that are greater than the function itself. So all of these values. So anywhere in this green shaded region, not on the line, because the line is dotted, would be where a solution is. So the question is, where is my solution? Negative 1 up 2. And sure enough, that coordinate, negative 1, 2, is sitting within the field, so it is a solution. Now on the next page, I have a nice, neat explanation of this here. So you can pause this here and finish up the problem and get a easy check. Checking inequalities is really easy. So sometimes we can graph them by hand. Other times we might need our graphing calculator. But for the most part, a numeric check will work really nice. So the question is now, how do I solve this inequality? Now, obviously, it's going to have multiple solutions here. There's going to be more than one number that I can substitute in for x, which would cause this expression on the left to stay less than 4. So let's see if you remember, and I might be showing it a slightly different way than your teachers had before. One thing I like to do is to get the inequality first by itself, the absolute value by itself on one side. So I'm just going to add 5 over to the other side, and I get this expression. Now, this is the method that I choose. I choose to think about the absolute value. Remember, what's inside of the absolute value always turns out to be positive once I take its absolute value. So what's inside of here could have been negative, and it could have been positive. So I've got two scenarios, and you probably remember we had to split these up. Excuse me. I have one situation where I just have x minus 2 itself, positive, is going to be less than 9. And then I'm going to have another situation where that expression inside the absolute value could have been negative. Make sure you use parentheses there. So we solve this two different ways. So let's start on the left. It's super easy. We just add 2 to both sides. So therefore, x must be less than 11. So over here on the right side, now I could distribute. It's up to you. Do you want to distribute first? You guys probably would do that. So negative x plus 2 is less than 9. So I can subtract 2 from both sides. And at this point, I'm going to divide by a negative. And if you remember, our rules is that the inequality changes direction because I divided or multiplied by a negative. So this is my method to solve. Now we're not done. Where are all my solutions? Well, if I think about this on a number line, and I would highly recommend making a little number line. So I've got -7 on the number line and 11 on the number line. And so I want all the values that are greater than -7, so open circle at -7, and all the values greater than -7, so I'm going to start shading to the right, but I also want all the values that are less than 11. So that's another open circle because I'm not equal to. So therefore, any number, decimals, fractions, all of those, in between those would be a solution to my given inequality. Now, sometimes we can then also write this as a compound inequality. And there's my solutions there. So you should really be able to graph it on a number line, excuse me, and also write the inequality set of all values that make it true. All right, let's try another one. Maybe you can try this one. You try it first, and then pause, and then maybe I'll jump in after you've tried it a little bit. So I'm getting x is greater than -2. So now I'm going to go to my number line. And I got open circles on each of them because I'm not equal to. And I want to be greater than -2. And I want to be less than -10. So there is a graphical, or sorry, on my number line, way to express my solution. The other way to express this then is through the two inequalities. We can't write a compound inequality because these don't overlap. So both of these would be my solutions. One other way you can do it as well is through interval notation. So I could go from -infinity all the way up to -10, not inclusive, get parentheses, not brackets, unioned with -2 up to infinity. Some of your teachers might have done that as well. And if we think about this real quick, let's take a sneak peek at the graph because I know what this graph looks like. So I've got x plus 6. That is just the absolute value function shifted to the left 6. So there is that graph. And what does the function 4 look like? I'll do that one in blue. The function 4 is just a constant function of 4 right there. So the question is, when is the absolute value function greater than this constant function? Well, it's greater for all values here and here. The absolute value function is above this line on those intervals. And anyone want to take a guess what this value is where they're intersecting right there? Well, yeah, it's -2. And what's this value where they're intersecting right here? Well, yeah, it's -10. So values greater than -2 and less than -10. So we can even use graphs to kind of check these in the end. But you guys probably spent a lot of time with the algebra last year. All right, I'm going to give this one a try, pause, and then we can jump back in. Oops, made a little mistake here. Forgot to change my direction when I divided by a negative. So what do I got here? So I've got quick little number line, 1 and 2. Close circles for both because they're both equal to. I want less than 2 or equal to 2, but greater than or equal to 1. And that sounds like all those values in between there. So I could also write this as a compound inequality, solving it that way. Or I could actually use interval notation, and it's brackets because it's equal to signs. That is still yet another way to express any value between between 1 and 2, including 1 and 2, would satisfy this inequality. All right, so got a couple on the practice worksheet. You can just, if you have a physical copy, you can work with that if you want to print it out. Otherwise, you can just do them in your notebook. Looking for the first 3 for you to just test them. So, and you can just test them by substituting in. The next 3 you should be, or next 4, you should be able to graph these. These are all our graphs of our parent function shifts and things like that. And then you're going to be doing the shadings. Be careful with solid and dotted lines with some of these. And then the last 3 are solving these inequalities like we just did recently. So make sure if you got questions, reach out and let me know. Good luck.